Assalamu alaikum. I am Abid Ibn Saif and this is the demo for our machine learning project. Um, Before we start, we did the project in three different steps. In one step, we did the EDA, exploratory data analysis. In another step, we build our model using only 5 epochs. And in another set, we build our model using 15 epochs. So at first, we already run this code for the simplicity and for the time saving. So we already pre-install all these libraries. So we are using Google Colab, and this pre-processing was done by brother Hanif. So what he used is he load the data from the dataset, train and testing dataset, which we collect from UCI machine learning repository. Then he leveled them, and that is the first few only 5 rows of the dataset. So then we go for the exploratory data analysis. As it mentioned here, this dataset contains 564 columns, and we can easily spot out that many columns contain same stem. So what brother Hanif did is he grouped them together like this, and because we are doing human activity recognition using smartphone data, mainly there are acceleration and gyroscope feature, and there were few gravity feature as well, which were then removed from the dataset. Then we checked for our missing value, as it was keep well maintained by the uploader. There was no missing values in the dataset. Then we are finding out the number of observation for each class. Then we are going for our EDA plot. So what we did was we tried to understand that our activity is differentiable. For example, in this EDA, we can see that using the clustering method, the laying is in one cluster, the groups are in, the formation of them is totally different from each other, although there are some variances and overlapping between them. And so it can be seen that those are easily identifiable, those activities are easily identifiable. Now after performing EDA, we were ready to build our model. So we used the framework Keras. So this was also done by brother Hanif. He built the model with 5 epochs, and he import pandas to and numpy to do uh, so basically he import pandas, numpy and matplotlib to do some calculation and storing the data as well. So for example, here he is loading a single file as a numpy array, so that's why he had to load the numpy. So in this section, what brother Hanif did was, in our dataset we had different text file containing the same set of data. So what he did was he combined all of them together so that we have a single dataset. So after combining all of them together, if we look at our shape, we can see that our train X and train Y shape is already given here. Our train X shape is this one, train Y shape is this one, and following so on and so on. Then he created a simple RNN model using these values, passing into this function. So in the verbose, what he did was, verbose is basically showing the calculation for all the epoch. So he set that as 0. So in future, when he ran his code, so there were no result showing that in each epoch how many accuracy was obtained. So again, I said that he was using 5 epochs to build a model. So he used the epoch as 5 and batch size was 64. Then he used number of time step as train x dot shape 1, which would be 128. Then he used the number of feature as train x dot shape, which would be the 9th feature we got from our data preprocessing, and number of output would be train y dot shape, which is this one, 6. So basically we have 6 activities, so that's why we have 6 categorical outcome. So in this section, brother Hanif did was he made this into categories, and now we are going for our model. So in Keras we have to write this model equal to sequential. Now this one is our input state, model dot add equal to simple RNN. There are 100 layers. Return sequence tree and input shape is train x dot shape 1 and train x dot shape 2, which is basically number of time step and number of features. Then we use four stacked RNN. And then we applied dropout as 0.5. Basically what dropout is, it is a regularization function. So what it does is it achieves it makes sure that our data is not underfitted or overfitted. So then we use a dense layer with 100 nodes, and the activation function would be rectified linear unit. And then we use another output layer, which in the end the activation function is softmax. So softmax function is basically will give us values between 0 and 1. So at the end we use the model.compile, and loss is as categorical cross entropy. So it will give us, so in using categorical cross entropy we can easily make sure that our output is in categories. And optimizer as ADAM. So the full form of ADAM is adaptive moment estimation. So we know about stochastic gradient descent. What stochastic gradient descent does is stochastic gradient descent maintain a single parameter for learning rate for the whole epoch, for the whole training set. And ADAM is actually combination of adaptive I forgot the name, RMS prop and AdaGrade, the combination of RMS prop and AdaGrade. So both of them are improved version of stochastic gradient descent. So using ADAM we can in single epoch, after the training on the single epoch, we can change our learning rate using ADAM. So at the end we want our metrics as accuracy. So then we fit our dataset using train X and train Y, and then we evaluate our dataset on test X and test Y, and we return our accuracy and model. So here we are running the experiment. So in here, to get the score in more literal form, we are multiplying with 100, and when run the model, so it gives us this following output, and the RNN model score is 59.179 using only 5 epoch. And the total parameter that was trained during the weight and biases was updated is 2106. So for the LSTM we decided to keep the same model as RNN, just using the LSTM function, and all of the rest are same, so that we can compare between both of them and see which model performs better. Similarly, our run LSTM experiment is also same. So after running the model, we get our model score in 71.463%, and the total parameter that was trained is more than RNN, is 376,306. So after that, what brother Hanif was trying to do, he did a precision recall F1 and build a confusion matrix, and from that he used the kappa score as well. So if we go for the result, we can see that RNN precision is around 59%, recall is around 56%, and the F1 score, which is the extended version of precision, extended output of precision and recall is basically 2 times multiply of precision and recall and divided by precision plus recall. So what it does is the F1 score is around 52% and the Cohen kappa is around 50%. So we can, from here we can see that the model performed badly. And for the RNN confusion matrix, Brother Hanif didn't write the level, but one is for laying, this one is for sitting, this one is for standing. But we can see that in the walking upstairs column, yeah, there are not many incidents which he can identify. Instead of walking downstairs, he classified all of them as walking upstairs, walking downstairs, and walking. So in the case of LSTM, the model improves a little bit, but not that much. So from this section, we can say that using only 5 epoch is not suitable for our code, because it is giving us if we evaluate the confusion matrix, it is giving us bad result, and also the precision, recall, and all the other things are not as good as it should be.